Hello friends, today we are going to discuss about two-dimensional relative motion and we have to continue with that problems. So problem number 18, man A sitting in a car moving at 54 km per hour observes a man B in front of the car crossing in the perpendicular direction and the road width is 15 meter and it is covered in 3 seconds, and what is the velocity of man B? So ultimately we have to find out a velocity of man B. So here man A, from the first statement, man A is sitting in a car which is moving with 50 km per hour. So velocity of A is equal to 50 km per hour. So it will become 54 into 1000 divided by 3600. So it will become 15 meter per second. So the velocity of man A is 50 meter per second. 15 meter per second. Now, so it observes a man B in front of the car crossing the perpendicular road of width 15 meter in 3 seconds. So the relative velocity of B with respect to A, that is distance divided by time. So distance is 15 and time, that is 3 seconds. So ultimately VBA, that is 5 meter per second. So ultimately we have to find out a velocity of B. So here a man is moving with 15 meter per second. So as per the vector diagram, man A, which is moving in the positive x direction, so VA, that is 15 I caret, it sees the perpendicularly the velocity of B with respect to A, that is 5j, and here it is the velocity of B. So now the vector diagram VBA, that is VB minus VA. So VBA, that is 5j, is equal to VB minus 15 I caret. So VB is equal to 5j plus 15 I caret. So the magnitude of VB, that is under root 5 square plus 15 square. So it will become VB is equal to 5, we have to common, so 1 plus 9, so 5 root 10 meter per second. So ultimately the velocity of B, that is 5 root 10 meter per second. So question 19, a man walks in rain with a velocity of 5 km per hour. The raindrops strike at him at an angle of 45 degrees with a horizontal. Find the velocity of rain if it is falling vertically downward. So from the first sentence, a man walks in rain with a velocity of 5 km per hour. So a man is walks in the rain with velocity of 5 km per hour. The raindrops strike at him at an angle of 45 degrees. The raindrops are striking with the angle of 45 degree of horizontal. Now we have to find out a velocity of rain. So ultimately the raindrops are falling vertically downward, but relatively it will happens that it will 45 degree to horizontal, and it will see by the observer that is 45 degree horizontal. So as per the vector diagram, this is a positive x and that is a negative y. So here we have to find out the velocity of rain if it is falling vertically downward. So here velocity of man, that is Vm, it is 5 into I caret Vr, that we have to find out. So here the relative velocity of rain with respect to man, so that is Vr minus Vm. So the relative velocity Vrm, that is Vr, that is minus Vr into j caret, because it is in the vertically downward direction, and Vm, that is in the positive x direction, so 5 into I caret. So if we draw the vector diagram, then here it will be minus 5 I caret, here it will be minus Vr into j caret, and the resultant is vector Vrm. So here a theta is 45 with the horizontal, so tan 45 is equal to minus Vr divided by minus 5, because it is in the third quadrant, so Vr divided by 5. So tan 45 becomes 1. So minus Vr divided by minus 5. So here Vr, it becomes a 5 kilometer per hour. So ultimately, if the raindrops are falling vertically, then the velocity of rain, that will become 5 kilometer per hour. So question 20. A raindrops are falling vertically with a velocity of 10 meter per second to a cyclist which is moving in a straight road. The raindrops appear to be coming with a velocity of 20 meter per second. Now the velocity of cyclist is, so this is a problem of a kind of rainman problems. So from the first sentence, raindrops are falling vertically with velocity of 10 meter per second. So here raindrops are falling vertically with velocity Vr of 10 meter per second. So it is in the negative y direction. So it will become minus 10 into j caret. To a cyclist which is moving on a straight road, the raindrops are to be appeared with a velocity of 20 meter per second. So it is appeared, so it is a relative velocity VRC, that is 20 meter per second. So ultimately we have to find out a velocity of the cyclist. So here a cyclist is moving in the positive x direction, that is VC, which is in the positive x direction, and the velocity of cyclist we have to find out. Okay, now the velocity of relative velocity of rain with respect to cyclist, that is VRC is equal to V R minus VC. Now the raindrops are coming vertically with a velocity of 10 meter per second. So here VRC, the magnitude of VRC, that is becomes V R square plus VC square, because VRC is equal to, that is VR in the negative y direction, so it will become minus VR into j caret minus VC in the positive x direction, so minus VC into I caret. So as per the vector diagram, here minus VR j caret and here minus VC into I caret, and the resultant vector VRC. Okay, so here VRC square is equal to VR square plus VC square. So VRC, that is 20 meter per second. So 20 square is equal to VR 10 meter per second. So 10 square plus VC square. So this is 400, this is 100, 400 minus 100, that is 300. So VC square is equal to 300, and VC, that is 10 root 3 meter per second. So here the velocity of cyclist, which is 10 root 3 meter per second. So question 21. A man running at a speed of 5 meter per second and the raindrops appear to be falling at an angle of 45 degree from the vertical. If the raindrops are actually falling vertically downwards, then the velocity is in the meter per second. So from the first sentence, a man running at a speed of 5 km per second. So here a man is running in the positive x direction, and the velocity of man, that is a 5 meter per second, and the raindrops are falling at the 45 degree with the vertical. So ultimately it making the 45 degree with the horizontal also, and the raindrops are actually falling at the downward direction. So it is vector VR, or we can say minus VR into j caret. So ultimately we have to find out the magnitude of the VR. So here VM, that means 5 into I caret, because it is moving in the positive x direction, and VR, that means it is minus VR into j, because it is in the negative y direction. It is in the negative y direction. So ultimately we have to find out a value of VR. So now VRM, that is a relative velocity of rain with respect to man. So it is VR minus VM. So VRM, that will become VR, that is minus VR into j caret minus 5 into I caret. So as per the vector diagram here, here minus 5I caret minus VR into j caret. Now the resultant, that is a VRM. So here the angle with the vertical is 45 So angle with the horizontal is also 45. So we have to apply a tan 45, that is tan 45, that is minus tan 45, that is minus 5 divided by minus VR, or you can change as a tan 45 minus VR by minus 5, because both the angles are 45. So ultimately tan 45 is equal to 1. So VR, that is 5 meter per second. So ultimately the speed of raindrops, if they are falling downward, then the VR, that is 5 meter per second. Now let me discuss question 22. This is a problem that is kind of riverman problems or ship or boatman problems. So question 22. A boat which has a speed of 5 km per hour in still water crosses a river of width 1 km along the shortest possible path in the 15 minutes. To find the velocity of the river water in kilometer per hour. So from the first statement, a boat which has a speed of 5 km per hour in the still water. So here in the rainman problem, if it is a still water, then the speed of 5 km per hour, that is in the northward direction, but here the river is also moving, so we have considered a speed of still water, that is inclined, and we have to complete the vector triangle like this, that is a speed in the still water, that is velocity of the river, and this is the shortest possible path. If this is a v, this is a u, then that is under root v square minus u square. So here velocity of the boat in the still water, that is a 5 kilometer. So velocity of boat, that is a v, in still water, that is a 5 kilometer per hour. So v is equal to 5 kilometer per hour. Now we have to find out a velocity of a river. Now it will given that it will crosses a river of width 1 kilometer in the shortest possible path within the 15 minutes. So here the river having a width of 1 kilometer, and it is approaching, or it is crossing within the 15 minute. So here a velocity, shortest path velocity, shortest path velocity, that is under root v square minus u square, that is distance divided by the total time. So here distance, that is 1 kilometer, and time, that is 15 minute. So ultimately under root v square minus u square, that is 1 divided by 15 into, it will become in minute, so we have to convert into hour, so it will become 4. So here v square minus u square is equal to 4, but v is 5 km per hour, so 5 square minus u square is equal to 4 square. So 25, 16, so u square is equal to 25 minus 16, so 9. So ultimately u is 3 kilometer per hour. So the velocity of a river that is 3 kilometer per hour. That is a velocity of boat in the still water, and that is a velocity that is known as a shortest path velocity. So ultimately the speed of a river, that is 3 kilometer per hour. So now let me discuss about problem number 23, that is also the problem of a ship kind of problem or boat kind of problem. So problem 23, a boat can go across in a lake and return in a lake. That time it is t0 and the speed is v. Now on the rough day, there is a uniform current at speed u to help the onward journey and impede to the return journey. If the time taken to go across and return on the rough day, that is t, then we have to find out the ratio of t divided by t0. T divided by t0 we have to find out. So ultimately in the case 1 here, it is a river, the length of river, that is a L, and the velocity of boat, that is a V. So ultimately the time, that is the forward and backward journey of the boat, that is T0. So T0, that is distance divided by the velocity. So distance, that is L and L. So 2L distance covered with the velocity of V. So this is the expression of T0, that is a 2L divided by V. Now in the case 2, here it is a river and the length of that river, that is L, and it is given that at a speed of V and on the rough day there is a uniform current at a speed of U to help the onward journey and impede the return journey. So here the ship motion is V to help the forward journey. So the current is in this direction and impede to the return journey. So here the return journey velocity, that is also V, but that is V minus U. So the time taken by that both the speed, that is T. So T, that is known as a L divided by V plus U for the forward direction plus L in the return direction, it will impede. So V minus U, forward direction it will help, and in return direction it will subtract. So ultimately T is equal to L V plus U plus V minus U divided by V square minus U square. So U cancel. So it is 2LV divided by V square minus U square. So T is equal to 2LV divided by V square minus U square. So ultimately we have to find out T divided by T0. So ultimately we have to find out T divided by T0. So the expression of T is equal to 2LV divided by V square minus U square, and the expression of T0, that is 2L divided by V. So T divided by T0, that is 2LV into V square minus U square into T0. So T0, that is 2L divided by V. So 2L cancel. So V square divided by V square minus U square. So in the second term, T divided by T0, if we are take in denominator V square, or you can say both the numerator and denominator, that is divided by V square, then 1 divided by 1 minus U square divided by V square. So this is expression of T divided by T0. So question 24. Two boats were going downstream with different velocities. When one overtook the other, a plastic ball was dropped from the one of the boat. Some time later, both the boats turned back simultaneously and went at the same speeds as before to relative water. Now we have to find out where the ball had dropped, which boat will reach at the ball first. So here two boats were going downstream with different velocities. When it overtook, at that time a plastic ball was dropped from the one boat. So here in the solution, if two boats are to be there, here it is a one river and two boats are to be there, they are going with the different velocities, and it overtook at that time one ball that is dropped in the river. So here the distance, here the boat A and B, distance covered by the boat A, that is a velocity of boat A with respect to water into time t0. Now distance covered by the boat B, that is SB, that is velocity of boat B with respect to water and time t0. Here both the time are same because at that time they are crossed. The one from the one boat the ball is a draw. Now after both the boats are simultaneously going in the same direction. So here now from the second sentence, here sometime later both the boats turned back simultaneously and went at the same place as before, in bracket relative to the water, towards the spot. Now where the ball had dropped, which boat will reach there first? So distance covered by both the boats, that is SA and SB. Now here from the second case, that is from the first case, now in the second case, here time, for the time TA for the boat A, that is for boat A, and time B, that is boat B. This is for the case A, and case B, TA and TB. So time, the expression of time, that is S, distance, and the velocity of A with respect to water. For TB, it is also SB divided by velocity of B with respect to water. So here from the first equation, it is the equation 1. So TA is V of A with respect to water into T0 divided by V of A with respect to TW. Same for TB, SB, that is V B with respect to water into T0 divided by V B with respect to water. So VB cancel, AW cancel. So TA is T0 and TB is also T0. So from the expression TA is equal to TB is equal to T0. This is an answer. So it will take a same time. So both boat will reach at the ball simultaneously. So in first case, if it is time taken is T0, if in second case it is TA and TB, then in first case and second case the TA, TB and T0, that are the constant, and the value of that is equal to T0. So it will take the same time because in case 1 and case 2 all the situations are same. So it will take a same time. Now question 25. So question 25, a river is flowing from west to east at a speed of 5 meter per minute. A man on the south bank of the river is capable to swimming at 10 meter per minute in the still water. Now it wants to swim across the river in the shortest time. He should swim in which direction? So here we have to find out a direction. So from the first sentence, a river is flowing from west to east. So from direction system, here north, south, east and west. So here a direction system north, south, east and west. So a river is flowing from west to east at a speed of 5 meter per minute. So west to east, that means river is flowing west to east and the speed of river, that is 5 meter per minute. Now a man on the south bank of the river that is capable to swimming at 10 meter per minute. So that means the speed in the still water, that is 10 meter per minute in the still water. Now it wants to swim across the river in the shortest time. So he should swim in which direction? So here now in the river main problem, here it is the speed of swimmer in the still water, so that is 10 meter per minute. This is the velocity to the shortest path, and this is a velocity of the river, that is 5 meter per minute. So here ultimately we have to find out, he wants to swim across a river in shortest path. So he should swim in which direction? So here a time taken by the man to the shortest path in the river, that is, if this distance is d and this is vs, the speed of man in the still water, then time t is equal to delta s by delta t. So delta s distance is d and delta t, that is v into cos theta. If this angle is theta, then it is vs into cos theta. Now here d is constant and vs is constant. D is a distance which is constant, and the vs, that is the speed of man in the still water, these both are the constant. So time t, that is directly proportional to 1 divided by cos theta. If we have to find out the shortest time, that means t minimum, so 1 divided by cos phi is maximum. If the denominator is maximum, then the time is minimum, so that will maximum in north direction. So question 26, a man is crossing a river flowing with velocity of 5 meter per second. He reaches a point directly across at a distance of 60 meter in 5 seconds. His velocity in still water should be, so we have to find out ultimately the velocity of the man in the still water. So here first of all, this is a river, this is a velocity of the man in still water, this is the velocity of river, and this is a velocity in the shortest path. So here a velocity of river, that is 5 meter per second, that is u, the velocity of river, that is 5 meter per second. Velocity of a man in the still water, that we have to ultimately find out, and here the shortest path should be reached in the 60 meter, the shortest path, that is 60 meter, and it will cover in 5 seconds. So here a shortest path velocity, that is 60 divided by 5. So shortest path velocity, if this is the v dash, then v dash, that is delta s divided by delta t. So delta s, that is 60 meter, and delta t, that is 5 second. So it will become 12 meter per second. So here, if u is 5 meter per second, so by the Pythagoras theorem, it is 5 meter per second, it is 12 meter per second. Then v, the velocity of the man in the still water, that we have to find out. So from that expression, v square is equal to 5 square plus 12 square. So v square is equal to 25 plus 144. So v is under root 169. So ultimately v is 13 meter per second. So the velocity of man in the still water, that is 30 meter per second. Now question number 27. Two men P and Q are standing at a corner of A and B of square ABCD, and the side of that square is 8 meter. They start moving along the track with a constant speed of 2 meter per second and the 10 meter per second respectively. So find the time when they will meet for the first time. So from the first sentence, here two men P and Q are the standing at the square of ABCD. Here it is a square of ABCD. Two men P and Q both are standing on a corner of A and B. Now here the side length, that is 8 meter, so it is a square. So here it is also 8 meter and here it is also 8 meter. Now the moving velocity of A, that is 2 meter per second, and the moving velocity of B, that is in clockwise direction, that is 10 meter per second. So now ultimately we have to find the time when they will meet for the first time. So here it is in the clockwise direction. So here first we have to find out the relative motion of P with respect to Q. So relative velocity of P with respect to Q, or the relative velocity of Q with respect to P, or the relative velocity of Q with respect to P. Here Q is moving with more speed, so we have to find out a velocity of Q with respect to P, that is VQ minus VP. Here VQ, it is 10 meter per second, and VP, that is 2 meter per second. So VQ, that is 10 minus VP, is equal to 2, so it is 8 meter per second. Now we have to find out the time when they will meet for the first time. So here time, that means the distance covered by the this A and B, relative distance divided by the relative velocity. So time, that is relative distance of Q with respect to P divided by relative velocity of Q with respect to P. So SQP, that is in clockwise direction, 8 plus 8 plus 8. So it is 24 meter relative distance divided by relative velocity of Q with respect to P, that we have to already find, that is 8 meter per second. So ultimately the time, that will become 3 seconds. So our answer they will meet for first time after the 3 seconds. So time, that is 3 seconds.